So we're going to look at the area above and below the x-axis when we take the integral of a function. So basically, the big idea is that areas underneath the x-axis are considered negative when you take the integral. So if the question asks to find the area, anything that's below the x-axis, you're going to need to force to be positive. So you're just going to take the negative version of whatever's under the x-axis, because if it's already negative, by making it negative, you make it positive, yeah? So we've got a situation here. We've got f of x equals x squared minus 4x. If I wanted to know the area that's bounded between the x-axis and the point 2 and 5, well, this part between 2 and 4 is clearly below the x-axis, so that's going to be negative. Then the part between 4 and 5 is above the x-axis, so that's positive. So we need to add them together, but we need to take the positive part of the part that's underneath the x-axis. So how we would set that up is like this. You'll notice that the area total is going to be equal to the integral from 2 to 4 of f of x dx. We need to recognize that the answer to this part will be negative. So we need to take negative of that part to make the entire thing positive, since we're trying to find an area. And then we have to add on the integral from 4 to 5. But this is positive, so that's fine. We can just add that on. Okay, the negative part's the tricky part. Okay, that's the part that we need to sort of wrap our head around. In this case, I'm just subbing in the function. We've got x squared minus 4x, x squared minus 4x. And then, yeah, you got to take the antiderivative. So the antiderivative of x squared minus 4x is x cubed on 3 minus 2x squared. And from this stage on, I would encourage you to get out a paper and pen, because these can get quite hairy. And I admittedly probably could have picked an easier function. But in the VC methods course, at least, you're expected to be able to crunch these numbers efficiently and effectively. So you need to get practice doing it. In any case, if we just keep going along, when we evaluate the definite integrals, hopefully you can recall from the fundamental theorem of calculus that you sub in the 4 into the x here, and then you sub in the 2, and you take them away from one another. So that's what we have going on here, and then the same thing going on over here. So it gets very messy. And I've probably made a mistake here somewhere, but the answer works out anyway. So we get this, we just make a bunch of simplifications. I'm hoping this part might be tricky to do by hand, but you can see the logic behind it is the most important thing. Okay, just remembering that this first bracket we need to make negative. So it's negative, and then as we said, this part will turn out to be negative. So it turns out to be negative 16 on 3. We make the whole thing negative. So it's positive 16 on 3 plus 7 on 3. And yeah, so we get, yeah, 9 on 3. Let me just check that makes sense. 16 plus 7 is 23 on 3. And that doesn't seem to me to be equal to 9 on 3, but let's check. This area is 5.33. This area is 2.33. All right, some changes on the fly there. I don't know how I got 9 on 3. 16 on 3 plus 7 on 3 is 23 on 3, which is, yeah, this area plus this area. So again, taking the positive part of this, 5.33 plus 2.33 is 7.666 recurring, and that's 23 on 3. So that's the area bounded between the x-axis and this curve between the points 2 and 5. All right, hopefully that clarifies things.